All right, well, hello everybody, and it is officially summertime, and I'm here working for you. It's summertime in the LBC. You know that song? It's by the Dove Shack. I would play it, but I don't have their permission. But when I was a young kid, it was Warren G and the Dove Shack, I think. We got this place called the Luther Burbank Center, and I done thought that's what they were rapping about. It was the Luther Burbank Center. Come to realize it was Long Beach, California. But when I first heard it, I was a kid. I was like, oh yeah, no, the Luther Burbank Center. I feel you. That is pretty cool on the summertime. Go catch me at concert. So today we're going to learn graphing. We're going to have it in Vertex Form. That's the Cash Money Beautiful form. So let's talk, people. Just real as an overview, you know, if you just kind of pick a random parabola, one thing you'll see is that there are some kind of points that are more critical than others. But I don't think you're going to get more critical than the vertex. It's the middle of the damn thing, right? And so when we graph, we're going to find the vertex first. And at that point, we've got options. So it's really about find that vertex, and then I would think it's about taking advantage of the beautiful symmetry of this lovely shape called the parabola. So step one, let us find the vertex. And for now, you can just ignore this thing over here. Now, in vertex form, remember, so this is going to be a minimum point, right? So it is going to look something like that. It happens when x is 3, right? So when x is 3, that means this green rectangle will be 0. And so x equals 3, and then y equals 1. So the vertex is going to be at 3, 1. All right, so let's put that here. So let's go x and y. And since it's the vertex, what I'm going to do, oh, there it is I'm going to put the vertex here. 3, 1. Boom! Cash money. And actually, that's not a bad spot. I just kind of guessed, right? But let me try to make what 3, 1 would probably look like. So we're going to go over 3 and up 1. So I'm going to put it there. I'm going to say that's our vertex. Okay? Okay, so we need some more points. Now, that one point you might go get right away is that y-intercept. So the y-intercept is always going to be the value of the function when x is 0, or when the horizontal axis is 0. And a lot of times, this axis in different applications is time. It's time. And so the y-intercept is really like, what's the value of the function when it begins? A lot of times that's what it is. So let's look at it. What we want to do is we want to go and see, well, what is it when x is 0? Well, you could plug it in and see. So let me try to find the best way to do that. So I'll try it right here. So this will be for the y-intercept. And you'll say, well, y is equal to, now you're going to make x 0. All right, minus 3 squared plus 1. Now notice 1 is not the y-intercept. 1 is the y value of the vertex. It's not the y, not in vertex form. That's not the y-intercept. So we got that to be 0. So this is negative 3. Negative 3 squared is 9. And 9 plus 1 is 10. And so y is equal to 10. There it is. Okay, so now I'm going to go here, and I'm going to go, that's at 10. So, you know, we're kind of, I'm going to use pink actually. I'm just going to put it up here. That's close enough. We'll just say that's 10. I know it's not perfect. Now what we want to do is we want to take advantage of the beautiful symmetry. We talking symmetry, people, of a parabola. Look. So we know that if you go down 3, it goes up 9. So what that means is that if we go up 3, it's got to go up 9. That's the symmetry and beauty of this shape. And so then you say, oh, there I go. So you go over 6, maybe it's to there, right? And up 10, and that's point, maybe call it out, 0.610. Now 3 points is enough to define it. I mean, at the end of the day, the more points you have, the more accurate you can draw the shape. And so it's possible that your teachers want more than 3. A lot of teachers want 5 points, okay? It's not a problem. You want 5 points? Hey, you want 5 points? I give you 5 points. You want 7 points? I'll give you 7. Hey man, what you want, huh? What you want? So if you need another point, I would just pick one. So maybe you go to 4. Just go real close to the vertex, grab a nice integer. Okay, there's 4. You should probably plug it in to see what it equals. So if that were 4, we would get 4 minus 3, right? So if you were just to write that, you get the 4 minus 3 is 1. 1 squared is 1, plus 1 is 2. Yeah, you know, I mean, so there's a point. 4, 2. Oh, ain't that beautiful? I tell you what, man, that's beautiful right there. And so you can go here and say, all right, so this is 3. So if you go over to 4, it's right, you know, there it is. And then use the beautiful symmetry of the parabola. What's she talking about? What's she talking about, huh? What's she talking about? There's your 5 points. 1. What you want? You want more points? I can get you more points. This is a kind of a beautiful shape, and one of the things you want to do is that if you notice that the a value is 1, then you can take advantage of a beautiful pattern of parabolas, which is why I have this written. So this is what y equals x squared. It's called the parent function of a quadratic, because it turns out that the squared component is actually what details the shape, right? A dictates the shape. And so if this is 1, which it often is for us, right, you can just simply follow this pattern. So if I was to do the exact same problem I just did, this would be another way to do it. Watch this. And you're like, oh, Mr. Miller, I ain't got time for no another way of doing it. Don't you worry. This is going to take me like a second. Watch how fast this is. You're going to be like, damn, Mr. Miller, that's quick. So you just look at it and you find the vertex. Okay. That's what, 3, 1. Okay. And at that point, you just follow the pattern, which is up 1 over 1, up 1 over 3, up 1 over 5, 7, right? It keeps increasing, and then 9. So you could just go up 1. It's got to be 2. It's got to go up 1, and now this one would have to go up 3. And then the next one would have to go up 5. And that pattern always exists for quadratics. There it is. That has to be the case. And so what you can do, like if you got graph paper, right? I don't have graph paper right here, but you would do something like this. You would have your beautiful graph. You would have found your over 3 up 1, right? And then here's all you do is you go over 1, up 1. That is definitely your next point. Ain't that cash money? Ain't that cash money, right? Then you go over 1, up 3. That's definitely the next point. Yeah, you know what I'm saying. I know you know what I'm saying. And you go over 1 and you're up 5. Oh my God, Mr. Miller. That's what I'm saying. How many points you want? You want another point? Hell, I'll give you another point. I ain't worried. You want another point? I'll give you another point. There it is. What you talking about? What you talking about? How many you need? And then, you'd probably be more accurate than I am, but I'm just kind of on a whiteboard, but that should be symmetrical, so it works on the other side as well. It's nice, right? I told you it was gonna be nice. I did tell you that. Let's do one more. All right. Couple things we want to do when we look at this. One, we know that it is going to be a minimum vertex. And we also see that the vertex is below 0, right? And so this is actually going to be something that would have y-intercepts. Like it has to cross 0. I mean, it would have x-intercepts. So it's going to be down here. It's going to be pointed up. Some things that we just want to kind of think about. Well, let's first find the vertex. All right, that's the starting point if we're going to graph this thing by hand. Well, vertex is going to be the minimum point. So, and I'll use this explanation a lot, since this green rectangle-ish thing has to be positive, the smallest y can ever be is -3, which happens when that's 0. And when is that 0? When x is -7, right? -7 creates the 0. Gangster. All right, so now what we can do is say, okay, well, when that's -7, that's going to be -3. And that's the vertex. Boom. Now, you want to go the super fast way? Oh, boom. A is 1. Holler, follow the pattern of the parent function, which says if this thing goes up 1, so if we're going to go to -6, let me use a different, I'll go switch to black, let's do brown here. If you go -6, this has to go up 1. Done. Yeah, right? Yeah, right? So let's get this thing graphing here. Let's get it going. Let's go get it. Let's go get it. -7, oh, come on, man. I want to highlight that. I want to put it over here, man. Come on. I want it over there. That's what we're talking about, because I want to be at -7, so I want to highlight this side of the graph. So let's go back 7, down 3, and we are here. All right? All right, so then if we go back 6, down 2 is like probably there-ish. And now let me grab my purple, right? So that's a +1. And so if you go +1 the other direction, no, that's +1, sorry. I mean, that's also +1. So if this goes the other direction, it's not really +1 down, it's more like -1, right? So really, if you want to think about this, and I know I didn't say this last time, but you probably want the arrows going the same direction. And of course, this is a minus because we are going down. Or you could say +(-1). All right, and that would get us to -8, which would also be -2, right? So that's the symmetry. That's what I was trying to point to here. So that's the over 1, up 1. Now if you go over 1, you got to go up 3. And so you'd be up to here. And that would be at -5 and 1. So let's get that point on there. How many points you want, man? Come on, how many you want? All right. Like I said, I'll be here all day. I can get you points. You want points? I got points. And so that's going to go +3. And then you build your parabola. Now, one of the things you can see is that it probably doesn't have a nice clean x-intercept, right? Because it doesn't happen at -5 and it doesn't happen at -6. So it equals 0 somewhere, but I'm not sure where. It also looks like the y-intercept's probably fairly large. But that's the other way you could do this problem. So instead of using this pattern which says +1, right? If you go over 1, up 1, over 1 up 3, and the next one is over 1 up 5, and then over 1 up 7, and then over 1 up 9, right? And it's symmetric always, okay? So this and that distance are equal, and you write your graph. And that works every time. It's quite a beautiful thing. Let me show you one more little detail, and we'll call this one good. So let's continue with the necessity of the vertex. So again, looking back at the same problem, another way of finding the vertex is to write it in vertex form. So you say, okay, so it's 1x minus, right, because the form is a minus. So in order to get it plus, I got a minus and negative. So you say, oh, okay, minus 7. Feeling good about that? You're like, yeah, I'm feeling good enough about it. And now we want plus, but you can see that's a minus. So if you're going to use structure, that means k would be plus negative 3. And so your vertex is at hk, which is negative 7, negative 3. And then so what you could do is you could ask yourself, okay, well, my other point I want is the y-intercept. I mean, you just might be one of those people who's like, I just like finding that y-intercept. I like to go get that thing. So let's go get it. Plug 0 in for x. Oh, I've already kind of have it started here. Man, I already had it started. Huh? And that's something else. All right, so you got 0 plus 7 squared minus 3. That's going to be 49 minus 3. Oh my God. So that's why it's like good to have flexibility in this world. The y-intercept, that's pretty far away. I don't really feel like graphing. I mean, it's way the hell up there. I'm like, it's way up there. Because parabolas, they actually increase really, really quickly. And so the fact that that's kind of far away from the vertex, perhaps you would say it's far away from the vertex, means that this number is pretty big. Pretty big. So it probably is better to just sit here and mess around with points that are closer. Now, if you forget the pattern, you know, over 1 up 1, over 1 up 3, over 1 up 5, just substitute it in. Like I know that this went up 1, so this is going to be minus 2. But if I didn't, I'm still good. Because look, I could plug in minus 6. Yeah, I could, and then minus 6 plus 7 is 1. Oh, you see where I'm going now. I know you see it. 1 minus 3, negative 2. Holla, that's right there. Now I take advantage of symmetry. That point is right there. Oh, you want a 5th point because your teacher asked for a 5th point, and that's fine. Ain't nothing wrong with that. Then just find a 5th point. Take negative 5 and go on back and say, all right, let's go get negative 5 and see what happens. Let's see. Uh-oh. 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 It's positive 1. 4 minus 3 is 1. You see what I'm saying? Like, and the pattern will just show itself. That's what it'll do. So to kind of rewind here, anytime you're graphing parabola, you know, you really want to start, I'm just going to graph a random one. You want to start with the vertex. And at that point, you can make a decision. You can decide to get that point because it's kind of fun, because you get to make x 0. You can decide to find these points. Sometimes they're easy to find. Sometimes they're, you know, take a little bit more time. Or you can just find any old points and just make sure you take advantage of the beautiful symmetry. So once you find that point, just copy it over. Now, I didn't draw this very well because, right, those distances should be the same. Well, it is what it is. And what it was my best effort, okay? So remember, be silly, be honest, and always trust your cape. Take care.